In this video, we will be demonstrating the compact multi-pump test set, the H85V. This versatile self-contained mobile unit allows students to investigate and demonstrate the performance characteristics of a range of different pump types. The reason an engineer chooses one pump over another in a product or application will vary according to variables such as fluid volume, accuracy, role of physical position, i.e. the gravity involved and the space available, the cost of purchase, and the list goes on. Understanding the optimum pump for different scenarios stands students in good stead for engineering in the real world. Let's take a closer look around the apparatus. The elements are all mounted on a rigid steel frame with casters at the bottom to make it easy to manoeuvre around the lab. With its own water source, no water supply or drain is required. Let's look at the different elements now. The dynamometer here drives the interchangeable pump modules and provides measurements of speed and torque. The quick release couplings allow you to quickly and easily change over the pumps. This means you spend less time fiddling around with changing over pumps and can focus more time on actual pump function experimentation. The raised reservoir stores the water, which is fed to the pump through an inlet valve. To prevent the system running dry, there's a float switch. Water then passes through a pressure relief valve and then a delivery valve. At this point, there is an inline flow meter for taking readings before the water returns back to the reservoir. Now onto the pumps. 6 pumps are available that attach to the dynamometer and water pipes using quick connectors. There's 2 main groupings of pumps, positive displacement pumps and rotodynamic pumps. The positive displacement pumps trap fluid in a fixed space, usually a cavity, and then force it into the discharge pipe. Generally, these are used to transfer thick fluids or dosing applications. Carry out the experiments to find out why. Starting with the gear pump, the H85A has 2 gears in a housing, one driven by the motor and the second driven by the first. The fluid is trapped by the gear teeth and the housing as the gears rotate. The gear teeth mesh and prevent the backflow of fluid. The fluid is then discharged on the outlet. The piston pump, the H85B, uses 2 reciprocating pistons that suck fluid into the chamber in one stroke and discharges with the next. The vane pump, the H85E, uses a series of vanes rotating to pump the fluid in a similar manner to a gear pump. The rotodynamic pumps now. These are pumps that transfer the kinetic energy of the motor to the liquid by spinning an impeller. As the impeller rotates, it draws in fluid, moving it along the discharge pipe. Generally, they're used to transfer high volumes or thin fluids. Have a go to see why this is true. Now the centrifugal pump, the H85C, uses the centrifugal force created by the rotating impeller to move the fluid. The volume collects and guides the fluid to the discharge port. Now onto the axial pump, the H85D. This utilises a motor-driven axial impeller. Mostly you'll find these in turbojet engines. This is different to the other rotodynamics as the fluid moves in the axial direction rather than radially. And now lastly, we have the channel impeller, the H85G, which uses the impeller to push fluid around a channel in the housing. This is particularly good at dealing with particles in fluid, being well suited to wastewater treatment. There's a whole host of measurement apparatus incorporated to allow you to fully observe the functioning behaviour of each pump, including electronic pressure transducers and temperature sensors, all displaying results here on the digital displays. The VDAS on board means that you can plug in a suitable computer with the free VDAS software installed for full data acquisition and analysis. You can also use the VDAS eLab capability for remote learning with this apparatus. By running these different pumps, students can calculate the pump performance and efficiency. They'll also get to see and hear what happens when a pump is not performing effectively and when cavitation is occurring. Within the user guide, students are taken step by step through experiments, including the effect of delivery pressure at constant speed, the effect of speed at constant delivery pressure, and the effect of pressure on pump performance. TecQuipment offers a range of different teaching apparatus for learning about pumps that you may also wish to investigate, including a few that I'll mention now, which are the centrifugal pump test set, the series and parallel pumps, the axial flow pump module, and positive displacement pump module. Links can be found below. Don't forget to like and subscribe to the TecQuipment YouTube channel for more videos like this. Thanks for watching.